Um, my name's Carol, and I have the pleasure of introducing our guest speaker for the afternoon is Andrew McGuire. He is working as an irrigated cropping systems agronomist for Washington State University Extension. He's been with them since 1999. Andrew helps farmers to implement sustainable solutions to irrigated farming challenges in the Columbia Basin of Washington. He is on the leadership team of the WSU Center for Sustaining Agriculture and Natural Resources. His current efforts focus on developing systems that build soils through high residue farming, as well as cover cropping. You can reach him online. I just started following him on Twitter. He seems to have a lot of followers and discussion about soil, and they get quite in depth with opinions. And I've enjoyed catching up on his past tweets on Twitter. So some of you may already be following him. So I'd like to turn things over to Andrew. Thank you.
All right, thank you, Carol. Let me share my screen here. All right. Does everybody see that all right? Okay, good afternoon. Oops, just a second here. Okay. Back in April of 2018, I wrote a blog post on regenerative agriculture. And in it, I had this table of various lists of soil health practices and principles. And I was looking at this last year, and I noticed a problem with the table, that some of the principles were actually practices, and that some of those practices could not be carried out, or they didn't work everywhere. I work in an irrigated cropping system where farmers produce vegetables, fresh for the fresh produce market, potatoes, onions, and carrots. And this last one, integrate livestock, will not work very well with these farmers because of the risk of contamination with manure. So when farmers in my region looked at this list, they see things they couldn't implement. So I decided to boil it all down to just principles and leave the practices to the local farmer. So I had to think about what the difference is between a principle and a practice. And basically a principle tells you what you want to happen, and a practice tells you how you're going to achieve that principle. So the principle is what, and your practice is how. What do you want to achieve, and how are you going to do it? Or put it another way, a principle is a rule of conduct that guides you in choosing your practices. And once I realized this, I went to work in kind of distilling soil health management to a list of principles. And this is what I came up with, maximize and minimize. So you have basically two soil health dials to adjust within your cropping system. Now, what are you maximizing? What are you minimizing? Maximizing photosynthesis, minimizing tillage. So building soil comes down to these two principles, in my opinion, and we're going to take a look at each one of them. So maximizing photosynthesis. This is all about intercepting sunlight to power plant growth and produce plant biomass. And that plant biomass is actually stored energy. If you look at biological energy flows on Earth, with a few minor exceptions, they all start with photosynthesis. And this includes the soil. As important as soil biology is, it's dependent on plant photosynthesis for its energy. Its energy, its growth, and its functioning. So plants use sunlight to fix carbon in energy-rich compounds. We know legumes, they're nitrogen fixers, right? Well, all plants are carbon fixers. They store that energy in their biomass above ground. The more photosynthesis we have, the more carbon is fixed, and the more fuel we have available to do good things in the soil. The energy comes in the form of dead plant material, roots, and shoots. Below ground, we have the roots and root exudates. The roots secrete root exudates. They also slough off in the soil, especially with perennials, which are always sloughing off roots. And that's the major source of energy for soil biology. Cover crop roots. This is a picture of cover crop roots under the residue layer. And so all these roots are exuding exudates and fueling the things that we want to happen in the soil. So there's this carbon flow through the soil that we don't often talk about. But back in 2006, Henry Jansen, a researcher from Lethbridge, Alberta, wrote this important paper. And he's talking about, do we hoard soil organic matter or do we use it? Do we try to store it up and get more and more organic matter in our soils, or do we try to use it? We talk a lot about soil organic matter levels, and there's benefits to having those levels increase, but storage of soil organic matter really doesn't fuel anything. We need that carbon energy flow to make things happen. And that comes from decay of plant material, including organic matter. I'll give you a minute to read this quote. This is another quote from that same paper. But you can see the part that I have bolded there, a relentless flow of carbon that's driving processes along the way. It's just like your pickup truck. If the flow of energy-rich carbon, in that case diesel, stops, so does your truck. Same thing with the soil. We need this flow through the soil. So we have two sides of soil organic matter, really. On one side, we have the store. It stores nutrients, it binds aggregates, and there's some other benefits. It can store more water in the soil. And then on the other side, we have the use it. It's nutrient release, it feeds the soil microbes, and the microbes do all the stuff that we want them to do. They both have uses and benefits. It's interesting that this Huron paper that's up there in 2016, they did a study of lots of different soil health measurements. And the one that was most related to crop yield, was the best predictor of crop yield, was how much of that carbon in the soil was readily available for use or decay or loss. So it was basically measuring how much fuel you had in the soil. So maybe, and this is what Jansen's pointing out, maybe flow is just as important as storage. They're part of the same coin because they're related. If you increase plant inputs and decrease the losses, then you're going to increase the storage. If you have high losses, like I work with a lot of growers that are raising potatoes or onions where harvest is a major tillage operation. If you increase your losses and you want to keep your storage same, then you have to increase your plant inputs. And this is why one of the principles is to maximize photosynthesis, maximize this input, because it can either go to soil organic matter or these losses. And maybe we shouldn't call them losses because some of those losses are actually beneficial. So let's look at these two principles. The first one, maximize photosynthesis. We have to look at both in space and in time. So you need to think about filling the space you have with plant growth and aim for full-time, full canopy as much as possible. And then on time, you fill the time with plant growth. Year-round plant growth is the optimum. But I doubt we could tell, especially in northern latitudes, if we missed a couple weeks or even a month over the course of the year, because the soils are used to that. They're not used, in the winter when temperatures are cold, they're used to getting through those seasons without a continuous flow of carbon energy. So I'm going to take a quick look at practices that can be used to achieve this principle. I'm sure you know about them. I'm not going to reveal any secret practices here, but I'm taking examples from our region, and it might be a little bit different from your region. First one is just the basic management that you already do. These are all important for maximizing photosynthesis, maintaining that full canopy. So pests. Pests can definitely reduce your photosynthesis by taking out that leaf area and killing plants. So this may require more diverse crop rotations, pesticides, a combination of the two. So in this way, you can look at pesticides as a way of getting at soil health because you're keeping that plant putting carbon into the soil. Soil nutrient management is going to require sufficient nutrients, optimum pH, a soil structure that's conducive to seedling emergence and root growth. And then water. If you have water, irrigation can also help maximize photosynthesis. So maximize time growing in the field. And there's ways to do this between cash crops because the soil really doesn't know the difference between a cash crop and a cover crop. Its roots, the roots are putting, in either case, the roots are putting carbon into the soil. So in our case, in our region, we have most of our farmers fill up our growing season with crops. We have double crops. We don't have many relay crops, a few intercrops, but it's not a bad deal to fill up your entire season with cash crops if you can, because again, the soil doesn't know the difference between a cash crop and a cover crop. You can have faster turnaround between crops with no-till and strip-till, and I'll talk about that in a little bit. We have a double crop here that was green peas, sweet corn, that was actually made possible by no-till practices here. We also do wheat, buckwheat double crops here. Again, those are all good for soil health. You can look at the different rotations here. And like I said before, filling up your growing season with cash crops is going to help you maximize that conversion of sunlight to plant biomass. Because the plants are always adding carbon to the soil, it keeps the flow going. Even if your soil organic matter levels do not increase because you have a year-round living plant, it's going to keep that soil carbon flow going. It also keeps the soil covered, decreasing erosion. Again, within the constraints of your system. You can see here a dry beans winter wheat cover with a cover crop after the winter wheat is going to have active rooting period of 92% of the time with just 3 species. So it doesn't have to be complicated. This is a good spot to say that these are soil health principles, but you don't get paid for soil health. So you can't always maximize photosynthesis and minimize tillage because there's a lot of different factors in terms of that you have to deal with in terms of farming. So this is going to be different in warm climates than in cold ones. It's going to be different in sandy soils than heavier soils. It's going to be different if you're growing potatoes than if you're just growing wheat. And perhaps maximizing photosynthesis doesn't make sense for making a profit, and you've got to stay in business. So this is where you kind of have to optimize these principles within your system. And I'm going to stress that they are soil health principles. They are not overall farming principles. Okay, then the other principle is minimize tillage. By minimize tillage, we maintain a mulch of crop residues on the soil surface, which is protection against erosion. When the soil is not disturbed, your roots, your fungi, your biological activity can do their thing. Your structure is built and maintained. As with maximizing photosynthesis, a lot goes into minimizing tillage. Smart crop sequencing, residue management at harvest, at planting, adjusting soil nutrient status. These are some of the, and I'm going to give you some examples of both principles from my region now. So with cover crops, relays, and intercrops, you really have both the principles working together. So no-till and strip-till are going to allow for faster planting of cover crops, getting that canopy up and going, that carbon flow going quicker. This is a mustard cover crop broadcast. They broadcast the seed after wheat harvest. Then they come through with an undercutter to kill the weeds, and that shallowly incorporates the seed. They don't have to actually take a planter out there. It works pretty well in our system. Of course, it's all irrigated, so that helps a lot. with that, especially with that small seed and the shallow incorporation. Winter hardy cover crops are great because they're going to provide that carbon flow in the fall and in the early spring. So winter wheat, winter triticale. We use brassicas. Arugula is one of the brassicas that we use that overwinters here. So there's a lot of different options there. Maximize photosynthesis by managing your species, your stand density, your row arrangement. This is a challenge in specialty crops like potatoes and onions, but there's things that can be done. Growers are innovating. In potatoes, this is just before fumigation in the spring. It's a cover crop. It's pretty sparse there, but it keeps the carbon going to the soil. It also adds some residue to stop wind erosion. And we've got a publication on what growers are doing in this way with these potato rotations online. Another way of thinking about this maximizing photosynthesis is that you can actually import photosynthate. So photosynthate is just what's produced by photosynthesis. And that's actually what you're doing when you're applying manure and compost. It's really the quickest way to increase soil organic matter. Part of it will go to that carbon energy flow, but a lot of it goes into storage because it's already been it's pre-digested, either through composting or in the ruminant animals that are producing the manure. It's often the most expensive way, but if you have manure or compost available and the price is right, it's a good practice. And it really fits in with that maximizing photosynthesis because you're taking the growth from a large area, so the plant photosynthesis from a large area, and concentrating it in a small area. So when we maximize photosynthesis and minimize tillage, they can provide control of erosion, because it really makes no sense to try to improve your soil if it's eroding at the same time. Wind erosion is what we have here. You see a satellite picture of one of our windstorms back, probably 10 years ago. And wind here preferentially takes away our best soil. It takes away the soil organic matter, the clay, and the fine silt. And our soils are fairly sandy in the first place. So this is taking away the best of our soil. It's like you have, if your soil is a cupcake, the wind is taking away the frosting off your cupcake. So those fine particles are important for protecting soil organic matter from loss. They're important for resisting soil erosion in the first place. So it's not just stealing your current soil health, it's stealing future soil health. Sometimes the same thing can happen with water erosion. It's sometimes selective. Sometimes it just takes everything. And this is probably what you're worried about out there, where you're a little more wet and you have water erosion. But it's the same idea. You need to protect your soils from water erosion, because again, it doesn't make sense to worry about soil or soil health if your soil is eroding. By doing both these principles, you're protecting your soil with crop residues. This is an example of no-till. This is direct seeded wheat into Timothy hay. We grow a lot of Timothy hay here for export to Asian countries. And this is a direct seeded situation with wheat. No-till in beans, about 25% of our dry edible beans are now no-till. And this is after, we do it both after alfalfa first cutting or Timothy hay first cutting. So they'll come in, they take off first cutting, they allow the alfalfa or Timothy to regrow a little bit, and then they either spray before planting or they spray it out right after planting. And so basically you have a hay bean double crop, and this is after the hay field is coming out of production. There's benefits in terms of profits, because you get two crops, and the first cutting of hay is the one that's worth the most. You also get some disease control benefits because it reduces the splash from the soil up onto the bean leaves. Strip-tilled corn or sweet corn. We grow a lot of processing vegetables. This is strip-tilled sweet corn going into an alfalfa field. We need to do strip-till because of our northern location, similar to you. The cool springs And a warm season crop like corn really does better under strip till than it does under no-till, especially sweet corn because it's not as aggressive as grain corn is. And then some of the grower developed systems. This is strip tilled onions. It provides some residue to stop wind erosion. This is a challenge, especially in specialty crops. Onions do not produce a lot of residue, so this is a system developed by farmers in sandy soils to prevent the sandblasting from the wind of onions. And we've got a publication of this online. Minimize tillage and avoid compaction. And so why is avoid compaction here, other than for the obvious reasons? It's because tillage, if you have serious tillage, it's going to require tillage to fix it. So you can't minimize tillage and have compaction because you're going to have to do that tillage just to fix the compaction. This was done, ironically, while spreading compost. So it's kind of 2 steps forward, 1 step back, but it's always a good idea to avoid compaction. Minimize tillage is going to protect your soils. I mentioned before, your soil is building biology, especially on that soil surface. Here you can see basidiomycetes, mushroom-forming fungi, producing your soil glues under wheat straw. Not only does it protect your soil, but it expands the root zone. You have root exploration all the way to the soil surface if you can keep it covered. This is in a dry climate. We see the roots come to the soil surface. It's going to build soil tilth there, better use of nutrients, enables broadcast nutrients without incorporation by tillage because you have so many roots up in that soil surface. And when you concentrate soil organic matter in the top surface, the top 1 to 3 inches, you get a lot of the benefits. Aggregation, increased infiltration, increased aeration, it resists erosion, and it does you the most good right there at the soil surface rather than using tillage to kind of homogenize your soil organic matter in whatever tillage depth you have. Integrate livestock. I look at adding livestock as a practice that facilitates the principles, both maximizing and minimizing. Especially, they allow you to add perennial crops. It adds profits from cover crops. It takes another level of management, labor, and skills. You have other markets to worry about, but it is a good practice for those that can fit it in their system. So the result of these 2 principles is basically soil health, or as near to soil health as I can see is practical. Your soil is protected, your organic matter is maintained or increased, your soil structure is improved, your nutrient cycling increased. And it does give you these NRCS from the US, and you see this listed under Regenerative Ag 2, these 5 soil principles, which are actually a mixture of practices and principles. It basically covers those. So we have 2 principles, many practices, and it leaves a lot of room for creativity and innovation with practices that are going to accomplish these principles. And then below I have the practices that facilitate, including livestock grazing. I got to keep going here because I got to get to the fungicides. So why not minimize disturbance? If you look back at the NRCS list that we have here in the US, it says minimize disturbance, and I use tillage. And a lot of those other views look at these inputs as disturbances. But I'd like to look at the research. What does the research say about this, and especially in terms of fungicides? So this is an infographic that was sent all over the internet a few years ago. And their idea of effects of pesticides on the soil were that there were no life forms in the soil, which is sterilized, requiring constant chemical input. Well, it's common to see this, but it's wrong. Reality is much more nuanced than either having dead soils with chemicals or living soils if you do away with chemicals. And the same goes for use of fungicides. Soil health is a slippery thing. What are we talking about? Are we talking physical condition, soil function, soil biology? You can get really caught up in chasing a fuzzy idea of soil health or promoting soil biology, but that's not all there is to it. And I want to tell you that not all the disturbances are the same, nor are they all serious. The effects on soil biology is mostly what's viewed as a problem, and there's a relation to function, but there's lots of redundancy in who does what in the soil, and there's no clear line from soil biology to soil function. So we have to weigh the trade-offs. And this is one of my favorite sayings in agriculture: there are no solutions, only trade-offs. It's kind of a paraphrase of what somebody else was talking about. They weren't even talking about agriculture, but I find that it fits very well. And it gets back to optimizing your system given your specific constraints. So back to fungicides. I looked at the research and overall effects of fungicides on soil. Well, surprise, fungicides kill fungi. However, at labeled rates in the soil overall, the effects are minor transient. That means transient means they're going to be over fairly quickly. They're generally at the soil surface, which makes sense. With regard to earthworms, they don't kill earthworms outright in general, but they reduce their size because they have to develop a detoxification process, which slows their growth. So the exception to all this is that we have certain fungi that may be more important than others, especially with soil health. We always hear of mycorrhizae, right? So mycorrhizae are kind of the fracking operation of the soil. The plant uses them to extend its reach and to extract more, just kind of like oil wells use fracking to extend their reach and extract more. They're often associated with soil health. How are they affected by fungicides? Conclusions of several reviews here. Fungicides in general reduce mycorrhizal fungal colonization and growth in general. It's dose dependent, so the more you use them and each application that gets to the soil. Now we often use fungicides just on plants, so this is depending on how much of that gets to the soil. But in general, long-term use and when large doses reach the soil are going to be worse. It's very species and fungicide specific. So certain fungicides like Benomil, up to 80% reduction was found in some of the papers I found. Systemic, so a full systemic fungicide that goes through the entire plant is worse than a locally systemic, is worse than contact fungicides. So here you have to weigh the benefits of a fungicide growth, because that's going to actually help you with maximizing photosynthesis, right? If you can keep that canopy full, your plant's healthy, they're pumping carbon through the soil versus the possible damage that it does in the soil, especially to mycorrhizae. This was just yesterday on Twitter. This is a researcher from North Dakota, and showing that mycorrhizal fungi are very tough. She was treating the soil with fungicide every 2 weeks for 4 months, and she still sees active, this is arbuscular mycorrhizal fungi in the treated soils and in the roots. So it turns out they're pretty tough. The other thing about mycorrhizal fungi is that we don't always hear the full story about them. There's trade-offs to agriculture, and they're not always a win-win. They're important in natural, undisturbed, low nutrient soils. So you see a lot of ecology research on them. But in a recent review, I found this in 2017, many studies have shown negative growth effects. And they do cost the plant. The plant has to turn over some of that carbon to them to get what they want. And sometimes the cost is more than the benefits, especially with crops that have been bred not for mycorrhizal colonization. So there's the resistance and disease resistance, that's sometimes. The colonized plants sometimes are more resistant to plants. And overall review, and these people know a lot more about mycorrhizal fungi than I do. In 2018, we conclude that management of AMF by farmers is not warranted until the benefits are just demonstrated at field scale. And this is because a lot of the research is done in greenhouses in pots. The other question we have to ask is, what are the effects of fungicides on mycorrhizal fungi and other fungi compared to tillage. So I looked up some research, compared them to tillage, and I'll give you a minute to read through these. The bottom two are conclusions of a review of the research. So in general, tillage effects are larger and longer lasting than those of fungicides. Also, if tillage is eliminated, then the effects from fungicides are lessened. So the combination of tillage plus fungicides is worse than just the fungicides by themselves. So if you're minimizing tillage, fungicides may be a good trade-off for you in terms of maintaining that crop canopy. Almost done here. So the effects of tillage are much higher with fertilizers than fertilizers or pesticides, with exceptions. Tillage, if you compare it to tillage, so tillage is going to destroy the habitat. It's going to break down aggregates. It's going to break down soil structure, breaks up your fungal hyphal networks, breaks up the residue cover on the soil, makes the soil prone to compaction, which requires tillage, adds a lot of oxygen, which burns up soil organic matter. And really, if you look at it, there are no pesticides or fertilizers, even fumigants. And I work with farmers that use fumigants for onions and potatoes quite a bit. There's no pesticides or fertilizers that come close to having the effect of tillage. And that's why I distilled that principle down to minimize tillage instead of minimize disturbance. I mentioned this before, that the soil has high diversity. There's redundancy of function that makes it resilient to many pesticides, but less so to pesticides plus tillage. Finally, science does not stay still. We had some bad pesticides. Generally, they're being phased out, and we have the newer pesticides we have are less, they have less detrimental effects on the environment. So the trends are good. They're going in the right direction. Unlike tillage, we haven't really improved tillage. We can reduce tillage, but we can't really improve it very much. So there's always exceptions. All of the effects and research usually puts on rates that are above labeled rates. At labeled rates are what I'm talking about here. You can always find research out there that the effects are much more, but if you check, they're usually above labeled rates. So back to this, there's a hierarchy of bad effects on soil health. Tillage and associated erosion, I would say, was much more than fumigants. Fungicides and insecticides look about the same depending on the product you're talking about and the target. Herbicides don't have very much effect on soil microbiology, including glyphosate. And then synthetic fertilizer is at the very bottom. It has some effects. They're usually fairly short term. So these are pretty simple principles, but when you, but for a farmer, it's not actually that simple, because you have to, again, you have to optimize these two principles within all those other factors: climates, markets, economics, crops, pests, soils, regulations, equipment, technology, and all those other inherent trade-offs in agriculture. Again, two principles, lots of practices, optimize them within your system. And here's my contact information and the location of where my blog posts are located. I'm also on Twitter, as was mentioned. And I'd like to thank Alan and the Huron Soil and Crop Improvement Association for inviting me. And with that, I'm open for questions.
Okay, if anybody has any questions for Andrew, if you want to turn off your mic or turn on your mic and ask your question, or alternatively, you can type it into the chat box and we can read it from there.
No questions.
Andrew, it's Alan Lyons here. Can you hear me?
Yeah.
Yeah. A question I posed on the email to the Huron Association. I've read a lot of your research over the past 2 or 3 years, following you on Twitter. Where do you see the most need for research in the next 3 to 5 years in soils and crops?
Good question. Well, first of all, most of the stuff I post is not my research. It's other people's research. But you know, this whole thing that I mentioned at the beginning of the presentation about the flow of carbon through soils, and how important is that compared to our soil organic matter levels? Now they're somewhat related, but we can measure soil organic matter levels very much. We've had that down for a long time. How do we measure that flow through the soil? We can take snapshots over time, but it's still not easy. And then how to interpret that, you know, those flows. How much flow do we really need to have soil health in our soil? How much do fluctuations in those flows affect our soil biology and its functioning? I have another talk on just-in-time soil health where I talk about there's specific times during the year where those flows may be more important than other times. So I think some of that research about the carbon energy flow through the soil would be very interesting.
All right, thank you.
Any other questions?
Oh, I can ask one.
Sure.
With plant breeding, does the amount of okay, if you're plant breeders, if you ever go to a place where they do selections for corn and beans and stuff, everything's done under fairly heavily fertilized and highly tilled soils. Are we inadvertently selecting for varieties that may not respond quite as well to you know, no-till and working with being in the presence of fungi and stuff like that?
Yeah, very good question. And I'm not a breeder, so I'm just kind of telling you what I've seen. I haven't seen any data on, you know, the tilled versus no-tilled. There are some, you know, with no-till, that crop establishment period is very important. So if you have a vigorous corn hybrid that's going to get through that period better, it's probably going to do better in no-till than it would than another hybrid or variety that doesn't have that early vigor. But other than that, I don't think we've been selecting for tillage so much as the roots and the high nutrient status. I think that's definitely, but then you have to think about what the alternative is. If you want to have varieties that work better in lower nutrient status, I think you probably are talking about lower yields too. Now, whether that makes sense in terms of profit, it may, but in terms of yield, I think we're looking at lower yields if we're going that direction.
Okay, thank you.
Yeah, there is research about looking at domesticated crops in terms of mycorrhizal fungi. And there, I think there is some evidence that at least some crops, because some crops are more dependent on mycorrhizal fungi than other crops, but those that are more dependent on it, you're going to be able to see differences when you inoculate, for instance, on those crops more than other crops that are not so dependent on those types of fungi.
Thanks.
Sure.
Okay, John Beardsley has his hand up there.
Hi, I was just wondering, so you were saying like that was great to see that information about the insecticides and herbicides and their effect on soil health. But I was a little bit confused. So the fungicides that we're using, like on say corn and wheat, they may be affecting the mycorrhizal populations, or it's negligible.
From what I found, unless there were certain fungicides, and I don't know exactly what you're using, but especially that Benamel, and I don't know whether, I'm not an expert on fungicides, but that one's, so there's specific fungicide materials or active ingredients that do have significant effects on mycorrhizal fungi. But in general, I would say that they didn't. They had short-term, small effects. Now there's crops where they were using fungicide drenches of the soil. Now that can definitely have a major effect, but where you're spraying it on the plants for foliar control of fungus, I did not see the big effects.
Okay, one other question, if I can. We do use a fumigant. We grow vegetables as well,
Yeah.
and in that case, like we've always big debate and years that it's too wet, we're not able to use the fumigants. But then we do notice, you know, higher disease pressure, especially if the rotations aren't as long. We're more likely to see effects on those. Like we find we'd only get about 6 weeks of benefit to the fumigants.
From the fumigant, yeah. Yeah, we use quite a bit of fumigant here for potatoes and onions, and you're right. The protection that you get is fairly short term, so that's telling us that the soil microbiology bounces back.
Right.
From what I understand, and there's people out there that know more about fumigants than I do, but what they tell me is that fumigants drop everything back, but the beneficials recover more quickly than the pathogens. So that's why you get that time where you don't have to worry about pathogens. It's not very long. And if you start using fumigants year after year on the same field, you're actually selecting for microbes that actually use the stuff, because it's just a carbon energy, you know, it's part of the carbon flow. You're just putting it in a lot of microbes don't like it, but there are some that do, and you're actually selecting for microbes that'll eat the stuff. And so there's Australian research that shows that if you use fumigants over and over, they become less and less effective because they're not in the soil very long. You have got a lot of microbes that'll just eat it and reduce the time that it's effective.
Okay. Yeah, we basically stopped using them. Thanks very much.
Yep.
Alan here, question. Do you have an opinion on the percent between bacteria and fungi in your soil for agricultural crops?
Everybody's got an opinion, right? Yeah, I've posted stuff on Twitter about the fungal bacterial ratio, and from the researchers that looked at it, there's problems. First of all, how you measure it. It's not something that's easily measured, and it's not something that's easily interpreted. So I would have a good deal of skepticism about guiding your practices based on the fungal to bacterial ratio.
Thank you.
Yep. Anything else?
I have a question. It's Carol. I was just wondering what comments you would have related to climate change and what farmers need to be thinking about related to our soils.
I kind of stay out of the whole carbon sequestration. So in terms of being part of the solution to climate change and sequestering lots of carbon in your soils, there's people out there that know a lot more about it than I do. But I would say you really have to separate in your mind soil health from carbon sequestration, because they are not the same thing. If you want to put a lot of effort into storing a lot of carbon in your soils, that's carbon sequestration. It may give you soil health, but it may be more expensive than just getting soil health through the carbon flows that I mentioned. In terms of the changes in the climate and how farmers, that's kind of very specific to your area, and I have no idea how the climate is changing in your area. I know in our area, we are getting longer falls, so we have longer growing season in the fall, but it doesn't seem to have changed anything in the spring. And so farmers are just growing, for instance, longer season corn crops and trying to fill in that extra season. Now we have irrigation, so water is not such a factor. I would say this, that soil health, especially in rain-fed agriculture, is all about water. The biggest benefits that you get from soil health are about how much water you can take into the soil and how much water you can store. Now, if you have irrigation, it kind of takes away that factor. And so soil health is actually less important in irrigated crops than it is in rain-fed crops. So in terms of if you have changing precipitation patterns, soil health would be a good way to mitigate those effects. Anything else? I think I've gone over time.
Okay, so good afternoon.
right.
On behalf of Huron Soil and Crop Improvement Association, I'd like to thank you, Andrew, for a great presentation. And also I might add that during this pandemic, it's great to receive a presentation like this. We're sort of homebound. And I'm sure we'll be implementing what we have learned today and hope for a successful 2021.
Yeah.
Thank you.
Thank you for the invitation, and I've enjoyed talking with y'all.